Hey ladies, sorry I could not be there today, but I figured this was better than nothing. Hopefully you had a good weekend. Let's get started. We're going to talk about estimating population proportion and confidence intervals today. So we've talked about a point estimate. That's actually what we talked about last week. So in order to find that, we're going to do the number of people that said yes, or that characteristic divided by our sample size. So let's just start with number one. It says in July of 2008, a university poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtained a point estimate for the proportion of registered voters nationwide who are in favor of the death penalty. Alright, so what we'll do is we're just going to divide the number of people that said yes, 1,123, divided by how many people we asked, which was 1,783. We're just going to divide those and round, so you can put the approximate. I'm just going to round to two decimal places, so 0.63. Okay, so we're just dividing. So here's the new part, confidence interval. A confidence interval for an unknown parameter consists of an interval of numbers based on a point estimate. In a random sample of registered voters, 53% favor candidate A with a margin of error of 3%. What is the confidence interval? All right, so we have our estimate, and then we have our error. And then what we do is it says there are three different ways that you can write this. So you can do your estimate plus and minus your error. You can actually complete that addition and subtraction. So if I do 0.53 minus 0.03, I get the 50, the 0.50. And if I add 0.53 plus 0.03, I get the 0.56. So that second one is actually doing the subtraction and the addition. And then number 3 is just saying that p hat is between the two numbers when you add or subtract. All three of these are acceptable. Number 2 is probably the most common way for you to see it. Okay, but how do we get that 0.03? How do we find that error? Okay, so it says these are the most common critical values. In fact, they're at the bottom of your Z table. So even on your MyMathHub when you're doing your assignments, they'll be there. But you have this little table here that tells you your critical values based on what confidence interval you're looking at. Okay, so number 2 says, in a survey conducted by Princeton Survey Research Institute. Did I miss a page? Was I supposed to go side to side? I think so. I'm sorry, guys. I was. That's on me. My bad. A level of confidence represents the expected proportion of interval that will contain the parameter if a large number of different samples is obtained. The level of confidence is denoted as 1 minus alpha times 100%. For example, 95% level of confidence, alpha is 0.05. Means that if 100 different confidence intervals were constructed, each based on a different sample from the same population, we would expect 95 of the intervals to contain the parameter, but 5 not to include the parameter. Your margin of error depends on 3 things. It depends on your level of confidence. So the more confident you want to be, so as that confidence interval goes up, the margin of error increases. Your sample size, as the size of your random sample increases, your error decreases. And then it also depends on your standard deviation. The more spread out your population is, the wider our interval will be, which means the larger your error is. So remember sampling distributions for p hat. These are things that we talked about last week. NP times 1 minus p has to be greater than or equal to 10 if it doesn't already tell you it's a normal distribution. The mean of the sampling distribution is our point estimate. And then the standard deviation of our sampling distribution, we would find using that formula. The square root of p times 1 minus p over n. We're also required that each trial be independent, so when sampling from finite populations, n, which is our population, has to be less than or equal. Our sample has to be less than or equal to 0.05 times n. All right. So constructing your confidence interval, you're going to do your point estimate minus the formula for the error and your point estimate plus the formula for your error. Okay, so let's break down that margin of error formula. So it has this z alpha over 2. This is just called your critical value. We'll talk about how to find that in just a minute. Hint, I already told you by accident. And then this is our standard deviation. Okay. And then how do we interpret them? A 1 minus alpha times 100% confidence interval indicates that 1 minus alpha times 100% of all simple random samples of size n from the population, this parameter is unknown, will result in an interval that contains the parameter. So, for a confidence level of 95%, find the critical value, z alpha over 2. So if we look at this, that would mean that we have 95% in the middle, which means there's only 5% left that we have to split between the two sides. That leaves us with 0.025 on each side. So that's why we're dividing it in half. That's why it has this alpha over 2. Okay, it's not crazy terrible. Find the area to the left. So when I'm looking at this, remember our chart and our calculator, it always finds. So this is what I'm looking at, and I'm finding the area to the left of that. So that's that 95 plus that half that was left over, so the 0.025. So that's why it's saying the area to the left is 0.975. So you can use your calculator or you can use your table. Either way is fine. I'm going to do it in my calculator. You can also, so if you're using your calculator, you're doing that second vars, and then inverse normal, which I think is number 3, and then typing in 0.975. Okay, so I'm doing second vars, yeah, number 3, and then 0.975. So rounding to 2 decimals, I get 1.96. So 1.96 is my critical value. Okay, these don't go down, they go over. Sorry, I keep forgetting. Alright, so this is what I tried to show you all ago on accident. These are the most common critical values. 90% is 1.645, 95%, which we just found, was 1.96, 98% is 2.33, and 99% is 2.575. So we can normally just use those. Those are the most common ones that you see. So number 2, in a survey conducted by Princeton Survey Research Associates International, 800 randomly selected 16 and 17-year-olds were asked if they'd ever used their cell phone to text while driving. Of the 800 teenagers surveyed, 272 indicated that they text while driving. The rest of them lied. Construct a 90% confidence interval for proportions of 16 and 17-year-olds who text while driving. The first thing that we want to do is we do want to make sure that this is considered a normal population. So I do need to do off to the side that 800 times P. I guess I need to find P first. So 272 divided by 800. Okay, when I do that, I get 0.34. And I'm just checking to make sure this is a normal population. Remember, that's where you're doing the N times P times 1 minus P and just making sure it's bigger than 10. This is 179.5, so it is definitely larger than 10. Okay, the critical value says that it says we're looking at 90%, constructed 90%. So our critical value is 1.645. 1.645. And I just use the chart at the top of this paper to find that. Okay, now I'm going to find my margin of error. To find my margin of error, I'm going to fill in that formula. So the first thing is my critical value. So 1 equals 1.645 times the square root of my point estimate, which is at 0.34, times 1 minus 0.34, all over 800. Okay, and then I'm going to type that into my calculator, and I'm going to round to the same number of decimal places for my point estimate. So since my point estimate is at 2 decimals, I'm going to round this to 2 decimals, and this rounds to 0.03. Okay, so then I'm going to write my confidence interval. So my confidence interval is my point estimate, which is at 0.34 plus and minus 0.03. Okay, so then I actually am going to complete that. It says we are 90% confident that the proportion of 16 to 17-year-olds who text while driving is between, I'm going to subtract first, 34 minus 3 is 31, and 34 plus 3 is 37. And I could also have written that like this, 31 to 37. Okay, but you're just subtracting to get the lower one, adding to get the larger one. Okay, so let's do it again. Same information, different levels. So the only thing that changed on this was 98% confident. Okay, so our point estimate is still the 0.34. Our critical value is what changes because that's based on our confidence level. So I'm going to come back over here. 98 is 2.33. Okay, my margin of error, I'm going to have to fill that back in. So it's going to now be 2.33 times 0.34, 1 minus 0.34, all over 800. Okay, and when I put that in my calculator and round it 2 decimal places, I get 0.04. Larger confidence interval normally means my error is larger. Okay, so confidence interval, I'm still using my point estimate, plus and minus whatever we got for our error. Okay, so now we are 98% confident that the proportion of 16 to 17-year-olds who text while driving is somewhere between, I need to subtract, so 34 minus 4 is just 30. You can put that last zero if you want, but you don't have to. And then 34 plus 4 is 38. Okay? Fact, the larger the confidence level, the wider the confidence interval. So it'll have to contain more values. Okay, so now we're going to go backwards. Now we're going to figure out what sample size is necessary for estimating the population proportion with a specific error. So we say, hey, we want to disclose how big of a sample do we need. Okay, and then that's our formula that we're going to use. Okay, the main thing is there's 2 different ways that you can do this. Your p-hat, which is your point estimate, can be used based off of an earlier study, or you can use 0.5. Now, you don't get to decide. Your problem is going to decide for you. So your problem is going to tell you, hey, there was an earlier study, then you use the earlier study. If it doesn't give you information about an earlier study, then you use 0.5. Okay? So it says a sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample should be obtained if she wishes her estimate to be within 3 percentage points with 95% confidence, assuming that she uses the 2000 estimate obtained from the survey. Okay, so we're using this formula right here. We do have previous information. Make sure any percentages get changed over to decimals, which means you move that decimal 2 places to the left. Okay, so we're starting with n equals. It says P, our estimate is this, so we're going to 0.824 times 1 minus 0.824. Okay, and then we have that critical value. Remember, our critical value is based on our confidence interval. So our confidence interval is 95%, so we would look up 95% in that chart. It's 1.96 divided by, and it has a big E for our error. This is what we want to be within 3 percentage points. So 3% is 0.03 squared. And then you just type that into your calculator. One of the biggest things that you need to make sure you do is that you always round up. Okay, when you type this into your calculator is going to tell you that it's 619.02, and you're going to be like, oh, the first decimal is a 0, so we're going to round to 619. No, you will always round up to the next whole number, because if you round down, your sample size will not be large enough to get the correct error. So we will say that our answer to this is 620. So always, 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 when you're finding your sample size, round up. I'm missing a page. Hold on, I just gotta find it. It's in here somewhere. There it is. Okay, sociologists wanted to determine the percentage of residents of America that only speak English at home. What sample size should be obtained if she wishes the estimate to be within 3 percentage points, 95% confidence, assuming no preliminary estimate is known? If no estimate is known or it doesn't give you one, we just use 0.5. So we're going to say 0.5 times 1 minus 0.5. Okay, we're going to use a half or 0.5 for our point estimate. 95% confident is what we just used, so that was 1.96. 3% for error, so 0.03, and then squared. Okay, so you'll type that into your calculator. When you type it into your calculator, you get something like 1,067.11. But remember, we always round up, so our answer to this would be 1,068. Okay, and that's it. So I would go ahead and start 9.1 on your homework. You will have 3 homeworks for this week, so hope that helps. Have a good rest of your day.